Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is again about vectors. Another discussion of vectors, so give you some tools so you should understand how to solve basic dynamics problems, because we will have to deal a lot with vectors. And so far, previous installation, we talked about vectors, how vectors are depicted as arrows, and to define an arrow we need to know its length and its angle. Two things completely defines the vector in the plane, two-dimensional. And then we started to move to projections. We said instead of defining length and defining the angle, let's talk about projection against one axis and against another. And that's where we stopped. We said, okay, we have system of coordinate, we have the vectors, and we have basic triangle. We make this is hypotenuse, and we look on this triangle and we say that AX is A cosine alpha and AY is A sine theta, and we have those equations that AX over A is defined as cosine theta and AY over A is defined as sine theta. And it's a basic trigonometry and basic things that you should know about triangles. What's remarkable here, that although I started with the length A, looking on this triangular, and I have AX, and I have AY, and I take the ratio, this ratio has nothing to do with the length. It's all completely defined by the angle theta. That's the remarkable thing about this universe. Because look what it is. If I take, for example, triangle which would be twice as long, then this would be twice as long, this would be 2A. But this triangle and this triangle are similar, and both of them have 90 degrees and this common angle theta, and so this will become 2AX. And so if I take the ratio of this to this, it would be AX over A. And the ratio of this to this, it would be 2AX over 2A, and 2 would be gone, it would be the same ratio. So no matter what similar triangle I take, this triangle, any triangle that defined by angle theta and has a 90 degrees, the ratio of this side to this hypotenuse would be completely the same, and it will not depend of what is A. So actually theta and sine theta are independent from just property of the angle. Sine and cosine are property of the angle. And maybe it's we need to talk about those first, and even before we move to tangents and projectiles of projection of vectors and system coordinates, let's talk a little bit about sine and cosine. So, for example, just looking on this triangle once again, if this angle is 0, this angle, so that means this hypotenuse is the same like this. So it would be AX and it would be A, and AY would be 0. So if theta equals 0, we have that AY is 0, 0 divided over A, so we will have that sine theta equals 0. Likewise, we can say that AX equal Y, so AX over A, it's 1, because those are the same, and this is cosine theta. So immediately we know what is sine and cosine of 0 degree. Okay, let's for example take a little bit bigger angle. Let's take 45 degrees, right? we have this, and those are the same, and those are the same, and this is a, and this equal to ax. So we can write the Pythagoras theorem, and it would be a squared equal ax squared plus ay squared, but I just said that this is the same as the same, so a squared equals 2ax squared, and we immediately have that, if we resolve this, we immediately have that 1 over 2, because I bring 2 here, equal ax over a, and this is squared. And so I immediately know that ax over a, and by the way the same ay over a, equals square root of 1/2. And but ax over a is cosine theta, so cosine 45 degrees, and it is ay over is sine 45 degrees. And I made here a trick, I multiply by 2, and this would be square root of 2 over 2. And this is standard. You can of course go to your calculator and plug this number, but I know that square root of 2 is 141 divided over 2, so it's roughly 0.7. And I know it without a calculator, and many generations knew it before invention of calculator. So okay, so we know this, and then we can, for instance, can go further, and we can say, what if this theta is 90 degrees? So if theta is 90 degrees, ax becomes 0. And ay becomes, this is a and this is ay. And so ay over a, it's sinus 90 degrees. And this is the same, so 1. Sinus 90 is 1. And likewise, ax equals 0. So if I divide 0 over a, it still would be 0, and it still would be cosine 90 degrees. So those things I can tell, and I advise you to memorize, not to memorize, you will come to remembering those numbers if you review this video many times, and in the course of my lectures those would be those numbers, those angles that I will use quite often, and it's a good idea to remember those. And last thing, we can also try to build a graph. Of course I can tell theta, moving, drawing those triangles, but they have a better way of doing things, and it's called the radius vector. So imagine we have this is x, this is y, and we have radius, and this radius is rotating this way. So we have this theta, so essentially we have exactly the same picture here. Exactly the same picture, only this is 1. And if a equal 1, then our equations becomes very simple. Ay over 1 equals sine theta, and ax over 1 becomes cosine theta. And who needs to write division over y? We have ay equals sine theta, and ax equal cosine theta. Fantastic. So this means this is sine theta, and this means cosine theta. And so if we will start tuning this, we can build at any degree, we can calculate this distance, calculate this, measure this distance, and we can build the graph. And ironically, you may say, well, who will do it? But everything is related on this universe. So not y. Let's put x and y. I will build the graph depending on the theta, and this would be my function. And my function would be sine and cosine. Ironically, indeed, there is a system when something is rotated, the frame is rotated in a magnetic field, and this creates a current, and this current produces energy, and this energy comes to all those lights and powers all this planet. And that's exactly through rotation of the frame, which is the same like radius vector. And so those sine function and cosine function, they are everywhere. So you better learn them not only with vectors, but you will meet them. If you will be in language arts, you will not meet them. But as long as you're already listening to me, I assume you would be in some STEM environment. And the sine and cosine will be everywhere, so I don't think you will lose anything by listening to this. So what I'm trying to say, if theta equals 0, this becomes cosine, and this becomes 1. And if I turn it to 90 degrees, but no one doing it in degrees, because degrees are arbitrary, they're doing it in radians. And this is pi over 2, which is exactly like 90 degrees. And pi over 2 is 3 over 2, 156, 157 something. So, if I turn to 90 degrees, cosine would be 0. Somewhere here it would be 0.7, and the graph would go like this. The sine will go that way. And I think there would be a problem in mechanics where those graphs will go, one will be sine, another cosine, so it's everywhere, as I said. So what will happen, sine go up, cosine go down, when 90 degrees or pi over 2, sine will become 1, and then cosine, if we will come here, for instance, to this angle, cosine will become this, it will become negative, and so it would be minus 1, and it happens pi, which is 3, and this becomes minus 1, and sine, this is this projection. As it rotates, this is the maximum, and it's 1, and it rotates further down, it starts to decrease, and it will come to this, and so we will have those sine waves that are everywhere, and it's not an accident. So, anyways, I can continue with this if I extend this graph further, and I put another 3 pi over 2, and I put 2 pi, which means full rotation. What will happen when theta will be pi? This would be negative. This projection will be negative, and then it will start when we reach this angle and go further to here. It will start to grow, and it will reach 0, and it will go like this. And as we rotate, it will repeat itself forever, and pi will go like this, and then it will go here. And we'll see that by making full 360 degrees turn, because remember 2 pi, 360, pi over 2, 90 degrees, pi, 180 degrees, or we come to the same situation, and then all those graphs start to repeat itself. But what's important? Important that when we have an angle, we have sine and cosine. and those are the function of the angle. Angle theta, or if you want angle alpha, or want angle beta, whatever you want. Whatever Greek character you want to use to denote the angle, and they use Greek characters for some reason. It's assumption, and everyone agrees to use Greek letters to denote the angle. So basically, when we started with this triangle, and we understood that A somehow disappeared when we're talking about sine, and then we can analyze it a little bit better, and we can understand that as the theta grows, we receive this angle. We also discussed what is sine and cosine in those kind of extreme situations of 90 degrees, 0 degrees, and also we took 45 degrees. We understood that sine 45 equal cosine 45, and we understood that it is square root of 2 over 2, and this is 0.7 approximately. And sine and cosine, we got it, it's 1 or 0, and it's minimum or maximum. The only thing that I will add to this math introduction to triangles and sines and cosine, I want to add another magic angle. And this magic angle is 30 degrees. And what's remarkable is that this thing, AY, the side opposite to 30 degrees, and this is A, and this AY, like this, sorry, 1/2. Or as they say, AY equal A over 2. So this side over 30 degrees is 1/2 of hypotenuse. And why it is so? Well, because if this is 30 degrees, and this is 90 degrees, and this is 60 degrees, and if we take a half of hypotenuse and put it right here, this would be 30 degrees, 60 degrees, and then this would be 60 degrees, and that means that this are the same, and because I divided it in half, this becomes the same. So this becomes half of hypotenuse, and I already say that this and this are the same. So you can follow this. I don't want to get too deep in this proof of this, but you can do it. It's basic geometrical fact. You can look in the book, you can look on this picture, and the only idea is that it is 30, and if this is 30, then this is 60. And if I draw it like this, it would be 60 as well, and this thing will be there. So what that means? That AY is equal, but this is AY over A, it's sine of 30 degrees. So we know that sine of 30 degrees is 1/2. And that's remarkable. And one other thing I can't resist. If I have this, and I have this, and this is 30, and this is 60, and I look on this picture, and I just said, let's call it A, B, C. C being a 90 degrees angle. So this is 30, this is 60. And I said BC, this, over AB, we just said that it was sine 30 degrees. But if I look on this angle, and I say BC over AB, same thing, but adjacent side. divided over hypotenuse, it is cosine. But the angle is 60. So, I can't resist, but I will stop on this a little bit in the next installation, because I don't want to overwhelm you. This is a math, some of this may be difficult for you, so I suggest you watch this video several times, and if you have the questions, please shoot it to me. If you have comments, please write it down. Please subscribe, bell and like, and my next installation will be talking a little bit more about that. Thank you.